Hi everyone and welcome to this tutorial on Rdworks, the software for CO2 lasers. Whether you're a beginner or looking to refresh your knowledge, this tutorial will help you get started easily. We will discuss the software's main features and tools, the functionality of the interface, designing and creating projects, and setting up work parameters. Let's dive right in. Firstly, we can begin with Rdworks interface. Each time we start the software, we're greeted with its main work surface, which can be organized in a few sections. A section containing the tools for design and editing, the area for setting up work parameters, and the control panel. In the design section, we can find all the tools used for creating or importing drawings and designs. In this area, located at the left section of the interface, we can find some rudimentary drawing tools for creating basic geometric shapes such as lines, polylines, circles, squares, rectangles. We can add text and more. Right underneath them we have the tools for mirror effect and the option to create a copy array of our design. In the upper left corner we can locate the main menu bar that contains all the main functions and settings in the software. Right underneath we can find the options for opening a new file, saving the current one, or to load a previously saved file. Right beneath is the section for vector transformations, where we can relocate our vectors, change their size, proportions and dimensions, or create an offset or change our vectors orientation and alignment. In the section work, we can assign layer parameters and adjust the power, the speed and the priority of the layer. The power of the laser beam and the movement of the laser head are the main parameters when working with CO2 lasers. The values we input for these parameters will determine the effect and quality of engraved or cut sections on our finished workpiece. In Rdworks, these parameters are intuitively organized in layers, and each layer can have a different color from the color palette assigned to it. We can access the layers parameters in the work section located in the upper right corner. Here we input the values for the layer's speed and power. In order to assign multiple layers, we need to select our vectors and from the color palette choose one of the colors that we want to assign to it. The color palette system makes working with multiple layers easy and intuitive. Every color represents a different layer and we can assign them accordingly. In the control panel named Laser Work, we have options to send the file into the laser's internal memory to control the entirety of the production process. We have buttons to start, pause, stop and resume as well. And we have other options that determine the methods for production. This panel is located in the bottom left corner. Okay, so let's see how all that looks in practice. I'm going to import a already prepared file, and I can do this by selecting the option import, which is located in the upper main menu bar, or by clicking the icon with a picture and a green arrow pointing towards it, which is located right below it, and it's easy to identify. It says import when you hover over it. Right next to it there is also an exporting option, but we won't be using it this time. What we need to do is to import our file. As we click on the import button, we are greeted with a new window where we need to locate our file. In our case, I'll be working with a DXF file, so we need to select it and click on the open button, which tells the software to attach our design on the work surface. After we've imported our file, we can proceed with assigning layers and layer parameters. So what I'd like to do is to engrave the text sections of our design and cut the perimeter around it. And we're going to do this by selecting the vectors and assigning them with a dedicated layer. A layer can be assigned by selecting the vectors and choosing one of the colors from the color palette. After we assign the desired color, we can notice in the upper right corner in the work section that the software has generated a new layer with our previously assigned color, and we can input our parameters in it. Before I do this, I first need to ungroup my vectors so that I can select them individually. All of this can be accomplished with the option ungroup, which can be found in the main menu bar. in the lowest section of the edit window. Or we can also locate it right beneath the main menu bar where we have designated buttons for grouping and ungrouping. After all the vectors are ungrouped, I can select them individually and assign the working parameters to each of them. So first thing I'm going to do is to remove the duplicate offset vectors that won't serve any purpose for our design, and I'm going to put all the letters in a single group. We can do this by holding the Shift key and clicking on all the vectors that we want to be contained in a single group. We make sure that we've selected all the letters and we click on the option group. And now if we click on any of them, the software will highlight all of them because they belong in the same group. Now we can assign this group with work parameters. We select the vectors and click on the blue color. With this, the software will generate a new layer in the work window with the color blue. The work mode of this new layer is laser scan, which means that the blue section will be engraved. Laser cut is a working mode for cutting, and laser scan is for engraving. The black colored layer right on top of the blue one has the status laser cut, which means that this layer will cut through the material. What we're left to do is to input the values for the working parameters of the layers. We can assign the blue layer on the remaining letters in our design, and I can add a simple geometric shape. In our case, a small circle, which I will position inside the bottom drawing, which will turn this design into a keychain. We can generate a perfect circle with ideal proportions by holding the control button while drawing it. The software will generate the circle with the blue layer because it was the last one used. So we need to change this and assign the black layer to the newly created circle. Alright, so we position our design in the adequate position and our keychain is almost ready to be produced. Next thing that I'm going to do is change the dimensions of my design so that it has the adequate proportions. On average, every keychain has length of 70 to 80 millimeters, so I'll need to change that. I select my design and I'll need to locate the size bar where I can change its proportions. This bar can be found in the section for vector transformations located in the upper left quadrant of the software's interface. The first two fields are displaying the current coordinates of the selected vector. In the X field, we have 300 millimeters on the X-axis, and in the Y field, we have 243 millimeters on the Y-axis. Right next to them, we have the two fields that we require. In the top one, we insert the vector's width, and in the bottom one, we input its height. The lock icon plays a significant role while changing proportions of our drawing. If it's locked, the vector's height and width are intertwined, and if we change one of them, the other one will change automatically in order to preserve the design's proportions. But if we unlock it and change its width, the height of the drawing will remain unchanged and our design will lose its proportions, and we can see how that looks in reality. If the key lock is unlocked and I input 80 millimeters, we can notice that the design lost its shape. This is not something that I want, so I will use the Ctrl-Z buttons to undo this change. I'll select the vector again, I'll activate the lock function, and I'll input the desired dimensions. Now the design has changed its size proportionally. Decreasing the width resulted in proportional decrease in its height. We can also change the vector's dimensions by percentage, and we can do this by changing the value in the adjacent fields. I'll increase the width by 5% and I'll enter 105% in the designated field. The keychain design will be manufactured from 3mm thick plywood. And what I need to do next is to assign the adequate parameters for cutting and engraving this material. In the work window located in the upper right corner of the interface, we select our cutting layer. In our case, it's the black layer, and right underneath it we can see that the software has displayed the values for its parameters. The two main parameters are the percentage of power that the laser tube will generate. In the software we have minimum and maximum power, and the speed of the laser head expressed in millimeters per second. Namely, the speed parameter is responsible for how fast the laser head will move across the surface of the work material. A noticeable similarity in the values of the parameters is the speed required for cutting and the speed required for engraving. Usually, for cutting, the speed required is drastically smaller than the one we use when engraving. Cutting speeds are with low values such as 7 millimeters per second, 11 millimeters, and so on, and the engraving speeds are above 220, 250, and sometimes 400 millimeters per second or more. For minimum and maximum power, these values, which are already assigned, are completely acceptable. In the priority bar, we set the order in which the machine will process the layer. It's always recommended to start with engraving and cut later. I'll input the number 2 in the priority field for the black layer, and the software will reorder the layers accordingly. The engraving parameters in the blue layer needs to be changed a bit, so I'll lower the speed and slightly increase the power value. If we want to get access to more advanced functions of our parameters, we need to double click on the letters laser scan or laser cut right below the mode column in the work section. After double click, we are greeted with a new window named layer parameters. In this window we have access to the advanced functions for the selected layer. Let's have a look at these parameters and see what they do. In the field output, if we select yes, the software and the machine will process this layer, and if we select no, we effectively disable the layer and it won't be produced. In the field below it, named speed, we input our desired speed. In the field beneath it, named repeat number, it gives us the option to process the selected layer multiple times. If I activate this function by checking the small cube and I input 3, the machine will process the blue engraving layer 3 times, one after the other. It will do the same job, 100% identical, but it will repeat it 3 times. The field below it, named processing mode, contains various processing types. Currently, our selected layer has the option laser scan set, which means that this layer is responsible for engraving. Laser cut is for cutting, and dot and pen are used for more advanced types of production. Right below this, we have the fields for minimum and maximum power. In our case, we can't input minimum power because the engraving function only uses the maximum value. I'll use this opportunity to explain why there are values for minimum and maximum power. We use minimum and maximum power only when cutting, and we can see this if we select the black layer. But why do we need these two values for our power usage? So when the laser head is moving across a straight line, it can very easily achieve the assigned speeds. But when there is a sudden change in direction, like in our design, the sharp corners of the keychain, they make traveling with constant speeds impossible. When the laser head gets close to the corner of the vector, it needs to start slowing down, decreasing its speed. It needs to completely stop at the edge, change direction, and speed up again so that it gains the assigned speed. The laser head itself has mass, so it also has momentum, and the software takes all of that into consideration. So when our laser head is moving with 100% of the assigned speed, it will use the value assigned in the maximum power window. But when it starts to slow down, when it stops and then speeds up again, it will use the minimum value for its power usage. All of these events occur in a very small time scale. It's impossible to notice them. This, however, will ensure that we have even cuts across the entire vector. The minimum and maximum power differ from one another for a small value, usually 2 to 3%. In the neighboring section of the layer parameters window, we have a few more functions. In the field scan mode, we have a few different options, and if we select, for example, X swing, the engraving process will be performed with fast movements on the x-axis and a very small incremental movements on the y-axis. And if we select Y swing, the laser bridge or its x-axis will move up and down along the y-axis with greater speeds, and the laser head will make incremental movements on the x-axis. So the opposite effect of X swing. Determining the distance for the small incremental movements while engraving can be done by changing the value in the field interval right underneath scan mode. The value in this field, in the field interval, is usually very small. It can go from 0.1 millimeters to 0.02 millimeters, which in itself is a statement for the insanely high precision of the machine. Once we're done with setting up the parameters for my keychain design, we will move on to the upper vector, which I will want to manufacture on plexiglass or acrylic sheets that have a reflective layer on the backside of the material. What I want to do is to remove the reflective material in the shape of the letter, which I can do by engraving it. And I also want to cut it off along the circled perimeter. Additionally, I need to make a small change. I need to flip the letter with the function mirror. We all know that text appears flipped in a mirror, and we can do the same effect in here with the function horizontal flip. We select the letter and click on the button horizontal mirror located in the bottom left section of the interface. Also, we can precisely position the letter in the middle of the circle by selecting both vectors and using some of the tools in the transform objects section. These tools are named center horizontal and center vertical. Now the letter R is aligned with the circle. Now we can continue with assigning parameters for plexiglass cutting and engraving. I will assign a different layer for the engraving of the letter and a different layer for cutting the circle. Different kinds of materials require different parameters. I will set up the red layer to perform engraving, and the green layer will be designated for cutting. I will input adequate values for the speed and power of these layers. And the only thing that remains is to change the size of my design, and I can do that in the section for transforming vectors. I see that the key lock is active, and once I change the height, the width will change proportionally. I'll reposition the drawing, and I can import an image for engraving. We click on the button import. We look up our image, and by double clicking on it or selecting it and clicking the open button, the software uploads and attaches the selected image on the work surface. When we engrave images, we can notice that in the work window where the list of the layers is, the layer for the image is classified as a BMP layer, and its mode is laser scan. The software uses a special type of layer when working with images, and you cannot change this. We will assign this layer with parameter values similar to those used for engraving, and these values may change depending on the type of the material. In Rdworks, there are additional options for setting up image for engraving, and these advanced options can be found in the green BMP button located in the section for transforming vectors. We select the image and click on the BMP button, after which a new window pops up named Bitmap Handle. In this window, we have options to regulate the brightness and contrast of the image. We can invert the colors of the image if we're engraving on plexiglass. We can set output resolution and choose the jitter effect, which will change the structure of the image. A classical image is made of pixels, but with this function, the software will generate it with dots instead of pixels. The density of the dots in a given area dictates the shape and brightness of the image itself in that specific area. This effect makes it a lot easier for the laser to process the image, and it usually turns out a lot better. Clicking Apply to View applies these changes to the image in the Preview tab, and clicking Apply to Source will apply this effect on the image on our work surface. We can click on the OK button and continue with the rest of the options. I will save this project as a Rdworks project file, and I can do that by clicking the button Save As, which can be found in the File window from the main menu bar. Rdworks will always save project files as .rld files. If we open one of these project files, the software will load it with already assigned and saved layers, parameters, and the positions of the vectors. This is quite useful when working on serial production. Seeing that I have already saved all of my parameters, I can remove the image and the vector for plexiglass, because the first thing that I'd like to produce is the keychain. With all the parameters and functions assigned, we can start with the production process. We position the working material on the work surface of the laser. We initiate the autofocus function, and the final thing to do is to click on the Start button from the section Laser Work in the bottom right corner. In this section, we have buttons to start or pause the process, stop the process completely, to send this file in the laser's internal memory, or to perform the go scale or cut scale functions. 99% of the time we will use the function go scale. This option is used to test the movements of the laser head based on the current scale of our design. When we click on Go Scale, the laser head will move around the boundary of our design without actually firing the laser. This helps us verify whether the design fits on our material and check for positioning errors before we start the engraving or cutting process. Essentially, the laser head will do a perimeter sweep around the area while it will work on our vectors. Another very important option in Rdworks is the option called Position, which can be found in the Laser Work section. For this option, we have a window with a few options to choose from. The first is named Current Position. We have Anchor Point, Machine Zero, and Absolute Coordinates. Most of the time, we will work with the option Current Position or with Absolute Coordinates, but 99% of the time I work with Current Position, and I only use Absolute Coordinates when I work on serial production. So what is the difference between them and what do they do? Current position tells us that the machine will start the production process from wherever the laser head is currently positioned. In the software, we can notice that near our vectors, in their top left corner, there is a small green cube. This cube indicates the starting position for our design. Namely, it's a representation for our origin point. The origin point is very different from the homing position of the machine. The homing position is located in the upper right corner of the work surface, and it's the position where the laser head will travel to each time we turn on the machine. The origin point is completely different. This point is entwined with our vectors, and it shows in which position the machine will start working from. When working with current position, the position of our design on the work surface is irrelevant. Once we click on the Start button, the laser head will instantly start engraving or cutting from the position it was in. And if we choose to work with absolute coordinates, we can notice that the green cube for the origin position has changed its location to the bottom left corner of the work surface. This mode uses the fixed machine coordinate system and its origin. When we start a job, the design will be positioned exactly where it appears on the workspace in Rdworks. This is great for precise, repeatable jobs, especially if you're using jigs or templates or you're working on serial production. In our case, we'll work with current position because it will make it easier for me to set up the design on the workpiece. I know the dimensions of my drawing and I can easily determine in which area of my workpiece I can position it. I use absolute coordinates when I'm working with templates for serial production. Let's say I want to create multiple copies of my keychain design and I want to use as little material as possible. There's a tool in Rdworks that helps you accomplish this. Firstly, we position and select the keychain design, and we click on the button Matrix Copy to create an array of copies from the selected vectors. The button Matrix Copy is located in the left section of the interface, right below the tools for creating geometric shapes. As we click on the button, a new window pops up named Array Copy, in which we have 4 fields. In the field X number, we enter how many copies we want along the X-axis, and in the field Y number, we determine how many copies should be generated along the Y-axis. Let's say I want to create 70 keychains, so I'll input 7 copies for the X-axis and 10 copies along the Y-axis. In the neighboring fields, X and Y space, we determine the distance between the furthest points of our design. After the software generates the copies, it will space them out from each other for the values that we enter in the spacing field. I'll input 3.5 millimeters along the x-axis and 3.5 millimeters along the y-axis. After we click on the button OK, the software generates the copies. These vectors are extra and I'll select and delete them. Now we are ready to start with the production. The software Rdworks is powerful and easy to use. It's created with intuitively organized tools and user-friendly interface. It offers its users easy and precise control for the machine, as well as flawless results for every design produced. Thank you all for watching, and I'll see you again. Bye.